Alright, let's look at the first free response question here. You got the equation given to you and its derivative given to you. And the first part they want you to sketch on the window. So it's just a matter of looking at the graph in your calculator and sketching a few key points. I would like to highlight just a couple of the points that are important. First of all, at this point right here, this graph is over here, so you've got an asymptote at -3. You can see that that was also given to us. That's the denominator is equal to 0. So you have an asymptote that's along the line here at -3. And this function looks like it reaches a relative maximum around -4 perhaps, and then again over here maybe at -2. So looking at your calculator a little bit closer will help you to identify those. And another thing I would pay attention to if you were asked to graph one of these is where it crosses the x-axis and approximate that. The second thing that I wanted to show you, perhaps you can see this, it looks like that it sets up nicely for a slant asymptote. It looks like it follows along this straight line right here. And so that's going to come to help you in part C, I believe. So obviously the sketching part, which I'm assuming would be worth probably 2 points, if not 3. This one is probably 2 or 3 points. This one's probably just 2, and this one's 2 as well. So just remember when you're doing these free response that anytime you can catch a point or 2 here or there, they all start adding up. So take your time when you're doing especially the parts that you know how to do. Make sure you justify everything with proper verbiage and sentences. So let's move on to part B, and they want us to discuss the range of y. Well, even if you don't give proper justification, you probably can at least get 1 point for talking about the range. Well, of course you could use your calculator to help you with this as well, but the range here, this graph continues towards -infinity, and it's greater than, and it's greater than or equal to this minimum, or excuse me, this maximum point. I guess we could call that A, and then it picks up again, and then it goes from this point picks up at a relative minimum at this point. And so on this side of the equation, the range differs a little bit over here. So how are we going to use the derivative to explain that? That's the question. Well, the justification for this, well, let's talk about rewriting this again first of all. I guess a better way to look at the range is that, let's see if I can find the highlighter here. This section in here is not part of the range, right? This is the only part that doesn't exist. So the function is going to, actually the easier way to rewrite the range is that y is going to be less than 8, or excuse me, y is going to be less than or equal to this a value, right? It exists down here, and then y is going to be greater than or equal to this value b. So really, all you need to do to justify this is to explain why A is a relative max, and be able to explain why B is a relative min. So how do you justify those? Well, so whatever the value is at A, I'll leave that up to you to find. You're trying to show that it's a relative maximum. So you have to look at the derivative. And if you look at the derivative to the left of A, the derivative is positive and the function is increasing. And then it looks like it has a horizontal tangent at A. So A would equal 0 there, the derivative. And then as soon as you turn the corner, it starts getting very negative. The derivative becomes very negative. And so that's how you justify a relative maximum. Of course, using a sign chart isn't what they want to see. What you want to do is just put that into words. Say that the derivative at A changes signs from positive to negative, making it a relative max. Alright, so let's go on, take a look at C. Part C says, what's the limit as x approaches positive or negative infinity of the first derivative? So we need to use the derivative formula given to us up here. And you look at this, and you can see that the highest degree in the numerator is x squared, and in the denominator it's just an x, but remember, if you FOIL that out, it will become 1x squared. So what is the limit as x approaches infinity from the left to the right? And the answer is, looks like a Betsy problem, right? So that would equal to 1. So the question is, what does limit as x approaches infinity? Part D says, what does your answer tell you about the function y? Well, part C, you're analyzing the what? The first derivative. So what does the first derivative tell us? Well, it talks about the slope of the tangent lines of the original curve. So as you approach infinity, the slopes equal 1. So if the slope is equal to 1, that tells us that what? The slope equal to 1 is going to give us, if we set this up in an equation, let's think about this for a second. The tangent line would be y minus y1 is equal to, let's write it in this notation, y minus f of a is equal to f prime at a times x minus a. So as we get larger and larger, well, this slope is always equal to 1, because we found that out from part C. So whatever this value is, f of a, and whatever a you choose, as long as it's a large value, the slope is going to approach 1, right? So that you need to be thinking about what kind of an asymptote we talked about in the first part. So hopefully these hints will help you, and the quicker you are with a calculator, the better you'll be on these type of questions.